In a diffraction pattern, due to a single slit of width A, the first minimum is observed at an angle 30 degree. When light of wavelength 5000 Armstrong is incident on the slit, the first secondary maximum is observed at an angle of what? Okay, what is this angle we need to find here? Okay, for the first minimum, the path difference between the extreme wave is, we can write it as, that is A into sine theta, A sine theta, which is equal to lambda wavelength. Okay, and this is given that when theta is equal to 30 degree, when theta is equal to 30 degree, then which corresponds to sine theta, that is a sine theta is equal to 1 by 2. Then we can find here A is equal to 2 times lambda. Then for the secondary maximum, the path difference between the extreme wave is given by, we can write it as sine of theta into 3 by 2 lambda. Using that means we can take it as here A is equal to 2 lambda. By considering this value, we will get this one. Then we can rewrite this one as 2 lambda is sine theta inverse is equal to 3 by 2 lambda. Solving that the theta dash is, we can find it as, that is sine theta dash is equal to 3 by 4, and thus theta dash is equal to sine inverse of 3 by 4. Then where we can see this one? Sine inverse of 3 by 4. Option D is our right answer.